buffer solution do not change on dilution. And best buffer is one in which pH is equal to pK or pOH is equal to pKb. 0.001 molar acetic acid having pKa 5 is half neutralized with NaOH. Then pH of the resulting solution will be, when you are neutralizing it, acetic acid will react with NaOH to give sodium acetate. As per question, half of the acid has been neutralized. So naturally, half of the salt will be formed. So when half neutralization has taken place, the solution contains equal volumes and equal moles of acid as well as salt. So it will form a buffer solution and the pH will be pKa plus log of salt upon acid. Concentration of salt and acid is same. So log 1 will be equal to 0. Hence pH will be equal to pKa. So the answer will be 4th. In the above question, when half of the acid has been neutralized, then on adding 0.0001 mole of HCl to 1 liter of this solution will. Now he has given you a buffer solution. He says if you are adding 0.001 mole of HCl to it, what will happen to its pH? Dear student, if this acid is added to water, that will change the pH of the solution from 7 to 4. But in this case, the pH, since it is a buffer solution, the pH will not change. If at all it will change from 5 to 4.9. Whereas in water it changes from 7 to 4. Hence the answer will be, does not change its pH appreciably. If a buffer solution having pH 8 is diluted 100 times, then again, dear students, its pH will not change because pH of a buffer solution do not change on dilution. He can also ask you, you are provided with 0.1 molar ammonium acetate having pH 6.5. Then if your friend takes 1 molar ammonium acetate, what will be its pH? Dear students, it is the salt of a weak acid, weak base. So it will behave like a buffer solution. Its pH does not depend upon concentration. You may take 10 molar, you may take 0.01 molar, you may take 0.001 molar. The pH in all the cases will remain the same. Now, the last topic in this is hydrolysis of salt. By hydrolysis of salt, we mean if a small amount of the acid or salt has been dissolved in water, it changes its pH. For example, you have a salt of weak acid, strong base. Let us say you have salt of sodium acetate. Then it is the salt of sodium hydroxide acetic acid. Then its pH will be more than 7 because from water it will consume H ions and give you undissociated acetic acid. As a result, certain OH ions will be more. So the solution will be basic in nature. It will be basic in nature. In the same way, if he says aluminium chloride, then it is the salt of a strong acid weak base. If the salt of a strong acid weak base is there, then its pH will be less than 7. In order to see whether the salt provided to you is acidic or basic, just see the presence of cations. If it contains cation of group 1 or group 2 elements and does not contain chloride, bromide, iodide, nitrate or sulfate, then dear students, pH will always be greater than 7. For example, sodium formate, sodium oxalate, sodium acetate, sodium carbonate, when dissolved in water, the pH will be more than 7. You can straight away tick mark, it will be basic in nature or pH will be more than 7. Again, he has given you a question. Then see, if it contains the anions chloride, bromide, iodide, nitrate, sulfate, any of these, but does not contain the cations of group 1 and group 2, that is to say alkali and alkaline earth metals, then dear students, the solution will have pH less than 7. For example, aluminium chloride, copper sulfate, zinc nitrate, ferric chloride, all these solutions have got the same anion which I have told you, chloride, nitrate, sulfate. But the cations of group 1 and 2 are not present. So these solutions will have pH less than 7. Just see the question. Which of the following solution will be acidic? CuSO4, NaCl, KNO3, HCONa. Go to that table and see. Sulfate is present in that table, but copper is not group 1 or group 2. It means the solution will be acidic in nature. So the answer is first. If we see sodium chloride, means for group 1 radical cation, alkali metal ions are present, chloride is also present. So if both are present, the pH will be 7. So if you get a question like NaCl, KCl, KNO3, NaNO3, it means the pH will be 7. So in the second and third, pH will be 7. But HCO1a, it contains alkali metal, but does not contain chloride, bromide, iodine, nitrate, sulfate. So the solution will be basic, pH will be more than 7. So the answer of the question number 2, which of the above solution will be basic, will be fourth.